Assalamualaikum and hi. My name is Nur Farisha Qistina binti Muhammad Nawar with metric number 85071. Today, I'll be presenting my final year project. So my final year project title is IT Equipment Loan Management System. So I'll be doing this for my bachelor's degree in computer science, major in information system with honors. So this project is supervised by Madam Rosita. So let me begin by providing some context for this project. So in today's modern academic environment, information technology equipment plays an essential role in supporting the teaching, learning, and administrative tasks. So here at UNIMAS, we heavily rely on various of the IT equipment such as laptops, projectors, cameras, and also networking devices to enable an efficient academic operations. So, currently, the borrowing process for IT equipment is done manually through paper-based forms, email communications, or even WhatsApp messaging with the IT technician. So, while this traditional approach has been in use for many years, so it is frequently results in several inefficiencies. So, which include that overlooked data, miscommunication, and also delays in the approval. This project also aligns with the Malaysia's digital economy blueprint, also known as My Digital, and also UNIMAS's own digital transformation framework. So both of which emphasize the importance of automating administrative processes to improve the service delivery and operational transparency. So therefore, this project proposes to address these challenges by developing an IT equipment loan management system using the Laravel framework to automate and centralize the entire equipment borrowing process. Now, let me elaborate on the specific problems we're addressing. So currently, many universities, including UNIMAS, rely on manual submission methods via email or hard copy papers for the IT equipment lending. This creates several operational inefficiencies. First, the communication gap. Borrowers, whether students or staff, frequently must contact with the technicians directly, which can be inconsistent and time-consuming. So this results in approval delays and frequent miscommunications between borrowers and administrators. Second, the lack of visibility. So there is no centralized database or system for borrowers to track equipment availability or track their request status. Users have no direct way to know if the desired equipment is available or how the request is progressing, so which leads to a scaling conflicts when multiple users inadvertently request the same device. Third, data integrity issues. So when records are kept manually, there is an increased potential for data entry errors, lost records, and even equipment loss. According to research by Al-Azizi and Rahman in 2020, similar manual tracking systems in other institutions resulted in a 20% rate of inaccurate data and an average 30% delay in equipment returns. So, finally, incompatibility with digital goals. So, in an era where digital efficiency is highly valued, and when Malaysia is pushing toward a digital economy, relying on outdated manual procedures is simply incompatible with our national and institutional digital transformation objectives. Therefore, a web-based management system is urgently needed to streamline processes and provide a real-time visibility and also improve communication between the IT equipment managers and users. So, based on these identified problems, the aim of this project is to develop a web-based system that centralizes and automates the IT equipment lending procedure at UNIMAS FCSIT. To achieve this aim, I have established 3 specific objectives, which is: first, to develop an online system that simplifies and centralizes the loan application and approval process for IT equipment. So this will replace the current fragmented submission channels. Second, to develop an intuitive platform that makes it possible to track status of requests, equipment availability, and return records in real time. So this addresses the visibility gap in the current system. Lastly, to evaluate how effectively the system works to enhance faculty management, communication, and transparency. This ensures that our solution actually delivers a measurable improvements. Let me clarify the scope of this project. So the system focuses on 3 primary user roles, which is first, the borrowers. So these are students or staff members who submit loan applications, check the equipment availability, and monitor the real-time processing of the request. Second, technician or IT freezers or approvers. So these are the FCS IT technicians who evaluate loan requests and decide whether to approve or reject them based on equipment availability and loan duration. Thirdly, the administrators who create the analytical reports, maintain user accounts, and oversee the system general operation. During the development phase, the UNIMAS scope is restricted to UNIMAS's Faculty of Computer Science and Information Technology, or FCSIT. So this version will be a web-based and accessible through browsers. There won't be a dedicated mobile application at this stage. The main focus is on increasing administrative efficiency for equipment loans rather than tracking asset maintenance or repairs, which could be added in future versions. For this project, I adopted the System Development Lifecycle, or SDLC methodology, which provides a structured framework for system development. So the SDLC consists of 5 main phases. Phase 1 is planning and requirement analysis. So during this phase, I gather the user demands from the department and potential borrowers through surveys and interviews to establish a clear system requirements. I'll share more details about this shortly. So phase 2 is design. So this phase where I focused on the database schemes design, the database schema design, interface layouts, and overall system architecture. So I use a case diagram, entity relationship diagrams, and also user interface mockups. So phase 3 is development. This covers the actual system implementation using the Laravel framework. So integration modules for user authentication and request management, and also notification systems. Phase 4 is testing. So the system will be tested comprehensively for functionality, usability, and security to ensure it meets all the requirements. And lastly, phase 5, which is the deployment and maintenance. So this final phase ensures that seamless operations and includes the ongoing enhancement based on user feedback. So this structured approach ensures that the system is built systematically with proper documentation and quality control at each stage. So before I designed the system, I conducted a thorough literature review to understand the existing solutions and identify the gaps. So I reviewed 3 existing systems, which is first, I reviewed on the UNIMAS Petari facilities booking. So this system provides an excellent user-friendly interface for room bookings with a real-time availability. However, it's limited only to room reservations and does not include any equipment loan or inventory management functionality. Second, the workshop equipment loan system, or WELOS. So this system successfully digitizes the equipment borrowing processes with a good approval workflow integrated with Microsoft Teams. However, it's limited by its reliance on Microsoft Forms, so lacks a real-time inventory tracking and restrict user to only 5 items per submission. Third is Asset Tiger. This is a comprehensive enterprise-level asset management platform with advanced features like depreciation, tracking, maintenance logging, and detailed audit trail. However, it's overly complex and expensive for academic IT loan operations, as it's designed for corporate asset lifecycle management rather than short-term equipment borrowing. So The key gap I identify is this no existing system combines academic focused design with comprehensive real-time tracking capabilities. So this gap validates the need for our proposed system. To ensure that our system truly meets the user needs, I conducted an extensive user requirement gathering through a mixed method approach combining the interviews and surveys. So I distributed an online questionnaire using Google Forms and received responses from 58 participants from Unimas FCSIT. So the respondents included primarily the fourth year undergraduate students at 79.3%, but also postgraduate students, academic staff, and administrative staff, providing diverse perspectives. So the survey revealed that some critical findings about the current system. So first, the visibility problem that is severe. 77.6% of respondents cannot check the equipment availability before submitting the request. This means that more than 3/4 of our users are working blind, leading to wasted time and poor planning. Second, the communication is a major challenge. So 48.3% have difficulty contacting staff and 39.7% experience unclear request status. So users don't know where their requests stand in the approval processes. Third, the approval times are inconsistent. So only 19% receive same-day approval, so while the 36.2% wait 1 or to 2 days, and 39.3% reported that approval timelines are completely unpredictable. Fourth, the overall satisfaction is low. So the average user satisfaction with the current process is only 2.76 out of 5, indicating that significant room for improvement. So, however, here's the most encouraging finding. 98.2% of respondents expressed that interest in using the web-based system for equipment management. So this overwhelming positive response demonstrates that a clear user readiness and demand for our response solution. So based on the survey, I identified the features user considers most valuable. So the top priority is a real-time equipment availability. So at 84.5%, users want to verify equipment status before making requests to avoid scheduling conflicts and unnecessary effort. Request status tracking came in at 75.9%. Users want transparency, so they need to know whether their request is pending, approved, or rejected without having to follow up manually. Online loan request submission at 72.4%. So we streamline the application processes by eliminating the need for multiple communication channels like email, WhatsApp, and walk-ins. Automated notifications at 65.5%. So ensure that a timely communication, users want approval alerts, status updates, and written reminders delivered automatically. Other highly valued features include the personal loan history at 63.3% for accountability and record keeping. So equipment search and filtering at 55.2% to help find specific items, and email notifications at 53.5% to keep users informed on important events. So importantly, that 63.3% prefer accessing the system via both web and mobile platforms, so which validates our decision to create a responsive web-based solution that works seamlessly across devices. So this user-driven priorities that directly shape our functional requirements and system design. And based on the requirement analysis, I established a comprehensive functional and non-functional requirements. So for functional requirements, the key capabilities include that user authentication and a role-based access control to ensure the security and appropriate permissions for each user type. So real-time equipment availability tracking, so users can see what's available before requesting. Online loan request submission with validates to prevent scheduling conflicts. So an approval workflow management system for the IT technicians to review and process the request efficiently. an automated notification system that sends email alerts for approvals, rejections, and return reminders. Comprehensive equipment and inventory management for administrators to maintain accurate records. For non-functional requirements, focus on the quality attributes. Performance, the system must load pages within 3 seconds and support at least 50 concurrent users without degradation. For security, all passwords will be encrypted using industry standard bicrypt hashing, and all data transmission will use HTTPS. The system includes protection against the SQL injections and cross-site scripting attacks. Usability. So the interface must be intuitive, requiring a minimal training with consistent navigation and clear error messages. Mobile responsiveness. The system must function properly on desktop, tablet, and mobile devices with a minimum screen width of 360 pixels. So these requirements ensure the system is not functional but also secure, performant, and user-friendly. Now, let's walk through the system architecture, starting with the use case diagram, which illustrates how different users interact with the system. As you can see, we have 3 main actors. The borrower, who represents student or staff. After logging in, the borrower can browse and search available equipment, view the detailed equipment information, submit the loan request, track their request status, review their loan history, and cancel the pending request if needed. So they also receive automated notifications about approvals, rejection, and return reminders. Next is the FCS detection, who manages the equipment loans. After logging in, technicians can view all pending loan requests, approve or reject these requests, confirm the equipment pickup when borrowers collect items, record equipment returns at the end of loan periods, and report the condition of returned equipment. They can also monitor the overdue equipment and send reminders to borrowers. The administrator has full control over system configuration. So administrators manage the user accounts, maintain the equipment records, assign user roles, view dashboard statistics showing system performance and usage, and generate the reports for audits and decision making. So they can also access audit logs to ensure that the system security and accountability. So this use case diagram demonstrates that each user role has distinct responsibilities and appropriate access levels, so ensuring the efficient workflow and proper security controls. So for the entity relationship diagram, so it shows that the logical database structure that supports all system functionality. So we have 6 main entities, which is the user entity that stores all the system user information, including the students, staff, technicians, and administrators, along with their assigned roles that determine the system access. Next is the equipment entity. So it contains the detailed records of all the IT assets, including the specifications, asset tags, status, and condition information. Next is the equipment categories entity. So it enables the systematic classification of different types of equipment, such as laptops, projectors, cameras, and also networking devices. So, the loan request entity is the core transaction component, which tracks every loan application submitted by borrowers, including the loan periods, request status, approval details, and return information. So this entity links to both users and equipment through foreign key relationships. The notification entity. So the notification entity stores the system-generated alerts, including the approval updates, rejection messages, and return reminders to ensure effective user communication. Lastly is the audit logs entity. So records all the critical system actions for security, monitoring, accountability, and system auditioning purposes. So the database design follows the normalization principles up to the 3rd normal form, or 3NF. So this ensures that the data consistency, eliminates redundancy, and supports efficient system operations. So Each attribute is atomic, depends only on its primary key, and has no transitive dependencies. So let me show you on the user interface designs, starting with the borrower perspective. So first, the login page serves as the primary entry point with a clean focus layout featuring email and password fields. A password masking for security, a remember me option for convenience, and a forgot password link for account recovery. So the design incorporates the Unimas FCSID branding to reinforce the institutional identity. Next is the borrower dashboard, acts as the main hub, providing quick statistics showing active loans, pending requests, and overdue items at a glance. So there's a notification panel displaying at the recent alerts, quick action buttons for a common task like browsing equipment or viewing requests, and a recent activity timeline showing that the user's transaction interaction history. Next is the browse equipment page. So allows users to search for equipment by name or keyword, filter by category, and availability status, and view equipment in a responsive grid layout with cards showing images, names, models, categories, and color code availability status badges. Pagination helps users to navigate through large inventories efficiently. Next is the equipment details page. So this page displays a large equipment image for visual identification, comprehensive specification, including model, serial number, asset tag, status, and condition, and an integrated loan request form where users can select start and end dates and specify their purpose. So if equipment is available, users can submit requests directly from this page. Lastly is the My Request page. So it uses a tabbed interface organizing requests into 6 categories: pending, approved, active, return, rejected, and cancel. So each request card shows that key details and color-coded status badges for quick visual recognition. So this design addresses the survey finding that 39.7% of users currently experience unclear request status. Now for the administrative interfaces. So the technician dashboard provides an equipment managers with an instant access to tasks that requiring attention. So it displays statistics, cards showing pending approvals, active loans, overdue items, and available equipment. So the main area shows that a pending request is a table with a borrower information, requested equipment, loan dates, and action buttons to approve or reject directly. And overdue equipment alerts section highlights items past their return date for follow-up. So when making approval decisions, a model window displays detailed information including borrower details, equipment specifications, loan period, and stated purpose. So the technicians can add approval comments to provide instructions or explain rejection reasons. So this streamlined design enables efficient decision making without navigating away from the dashboard. Next is the administrator dashboard. So this page offers a comprehensive system oversight through detailed statistic cards showing the total equipment, total users, monthly requests, most borrowed items, active loans, and overdue items. So interactive charts that visualize the key data, including the request status distribution. So equipment utilizations, trends over time, and popular equipment categories. So a recent system activity log at the bottom provides an audit trail of user logins, equipment additions, requests, approvals, and also administrative changes. So for the equipment management page, so it enables the administrators to maintain the inventory database with a sortable equipment table, search functionality, filter options by category, status, or condition, and action buttons for editing or deleting records. And add new equipment form captures essential details, including the name, category, model, specification, serial number, asset tag, purchase date, image, status, and also the condition. And for this project, the technology choices for this project, for the backend framework, I selected the Laravel version 10.0. So Laravel is a PHP-based framework that follows the Model View Controller MVC architecture, providing built-in features for authentication, routing, session management, and database migrations. It has excellent documentation and a large community for support. So for database, I'm using the MySQL version 8.0, an open source relation database management system known for reliability and performance. So it integrates seamlessly with the Laravel through the Eloquent ORM. For the front end, I choose a Bootstrap version 5.3, provides the responsive design components, ensuring the interface works well on all devices and screen sizes. So for the development tools, I'm using Visual Studio Code as the IDE and XAMPP for the local development environment, and Git with the GitHub for version control and code repository management. So these technologies were chosen because they are industry standard, reliable, well documented, and cost effective. So they work together seamlessly to create a robust development environment that facilitates efficient coding, testing, and deployment while adhering to software engineering best practice. So upon successful implementation, this project is expected to deliver several significant outcomes. First, the automation of manual processes. So the system will replace the current manual and email-based procedures that are prone to delays and errors with a streamlined automated workflow. So second, a real-time tracking capabilities. So all users will be able to submit and track their loan requests in a real time, while administrators can effectively handle approvals, monitor equipment and availability, and update written records efficiently. Third is improved communication. So automated email notifications will inform the users when requests are approved or rejected. So reminded them of the upcoming return dates and alert them about the overdue equipment, ensuring timely returns and reducing the overdue cases. Fourth is the enhanced data accuracy. So the centralized database will reduce human error in record administration and maintain accurate equipment history and condition logs. Next is the better decision making. So reporting and analytical tools will allow the administrators to track the utilization statistic, identify commonly loaned items, monitor borrower trends, and highlight the equipment that needs maintenance. Finally, the institutional alignment. So the project supports the UNIMAS's digital transformation that initiated by the promoting a centralized, paperless, and user-friendly platform for IT equipment management. So overall, the system will enhance operational effectiveness, accountability, and user experience in faculty IT equipment loan management. So this project holds a significance from multiple perspectives. So for the borrower, the students, and staff, the system provides a straightforward interface to request and track the equipment loans, eliminating the frustration of unclear processes and lack of visibility. So they benefit from the real-time equipment availability information and automated notifications, keeping them informed. So for the IT technicians and staff, so the system reduces the administrative workload by automating the routine tasks, provides a better control and visibility over the equipment, inventories, and loan schedules. Also eliminates the need to manually track the requests across multiple communication channels like email, WhatsApp, and walk-ins. So for the institution, so this project supports the UNIMAS digitalization initiative by implementing a paperless, environmentally friendly process, promotes sustainable IT asset management, which boosts the productivity and resources efficiency. The system demonstrates that UNIMA's commitment to technological innovation and operational excellence. Looking ahead, the system's scalable design means that it can serve as a model for other departments looking to digitize these similar procedures. So it establishes a foundation for future enhancement, such as integration with other campus system, mobile application, or expansion to additional faculties. So by addressing a real user needs demonstrated through our survey data and aligning with institutional goals. So this project delivers a practical value that extends beyond just technical implementation. So lastly, to conclude, this project addresses the critical inefficiencies in the current manual equipment loan system at Unimas FCSIT. So the development is grounded in solid user-centered design based on comprehensive requirements gathering from the 58 survey responses and stakeholder interviews. So the findings clearly demonstrated that user dissatisfaction with the current process and overwhelming support for a digital solution. So this proposed system provides a comprehensive solution covering all stakeholder needs through 3 distinct user roles: real-time availability, tracking, automated workflows, and a detailed reporting capabilities. So the design aligns with the institutional digital transformation goals and follow the software engineering best practices using proven technologies and methodologies. So moving forward, the next step also included in the chapter 4, which covers system implementation, the actual coding and development of all modules and features. Chapter 5, which focuses on system testing and evaluation, conducting comprehensive tests and analyzing system performance against our requirements. And finally, deployment and maintenance to ensure the system operates smoothly and continue to meet evolving user needs. Thank you very much for the attention. So I'm now happy to answer any question if you have. You may have about the IT equipment management system, can contact me through email or my number. Thank you.